Hello, this is Dave Birmingham. Today I'd like to continue on to part 2 of my series of configuring a 2-node multi-site cluster on Windows Server 2008 R2. First part of my series is available on my blog clusteringformeremortals.wordpress.com, and so this is a continuation. In part 1 we got to the point where we configured a basic 2-node cluster with no resources. We talked about using the node and file share majority quorum type and why that's important, and some ideas of where to place your file share witness. And we got to the point where we have a 2-node cluster, so that's where we'll pick it up from today. So first thing we want to do is let's look at the Failover Cluster Management GUI. So if we go there, Failover Cluster Manager, we will see where we left off with the 2-node cluster. So we have this cluster called Hyper-V cluster, and you can see that it's a node and file share majority cluster type, and we currently have no services or applications defined. So for a multi-site cluster, the key is that you need to have some kind of data replication. It could be array-based replication, from people like EMC and HP. They all have array-based replication and solutions that plug into Windows Server failover clustering. Or you can have host-based replications such as SteelEye DataKeeper from my company. So today I'm going to demonstrate how this works with SteelEye DataKeeper. So this particular part of the configuration is going to be very dependent upon your replication solution, so you're going to have to work with your vendor very closely to get the instructions and details of how to integrate the replication with the failover clustering. For DataKeeper, it's pretty simple, so I'm going to show you that so you have an idea of how it might work. So we're going to go right to the DataKeeper GUI, and I have that open here. It's pretty simple. You're going to install DataKeeper on all the nodes of your cluster, and because it's a host-based replication solution, so we're going to replicate the F drive. In this particular example, we're going to replicate the F drive between the first node, primary node, and the secondary node in our cluster. The F drive can be any storage type, and the storage types don't have to match. So for instance, the primary server might be attached to a nice EMC SAN in your primary data center for everyday use, but we're going to replicate it to a much less expensive iSCSI target device in your disaster recovery center. So maybe you don't have the budget to buy 2 large SANs for one for your primary, one for your secondary site. So we can replicate between any storage type, whether it's local attached to iSCSI, to fiber channel. It doesn't matter, as long as it shows up as a local disk on the nodes of the cluster. We will be able to replicate between the volumes. So we're going to go ahead and create what we call a job. And a job in DataKeeper is just a collection of related mirrors. So in this case, we're going to give this job a name. We'll say F drive, and a description, and we'll say async replication. Eventually we'll do a Hyper-V resource on this F drive. So we'll create the job, and this will launch the new mirror wizard. And so you can see it's already found the source server Hyper-V1, and it's good. Let's choose the network that we want to replicate across. In this case, it found the private network. We want to, if at all possible, keep the replication traffic on a private network. It's not required, but it's recommended practice to keep it off your public network. And then the volume, found the F drive, so we'll just go ahead and hit next, and then choose a target. It's already found the target Hyper-V2 and the right network adapter and the right volume. So we'll just go ahead and click next again. And here are some choices we have, whether or not we want to compress the data as we send it. So there's 9 different compression levels, or whether we want to choose an asynchronous or a synchronous mirror type. And we also can put a limiter on how much bandwidth do we want to use. So we can limit the amount of bandwidth, especially in the initial mirroring state, we'll use whatever bandwidth is available. So if you want to make any of those changes, you can change them here. You could go back later after the fact and make changes to these as well. So we'll choose the default settings and we'll hit done. And so it's creating a mirror, and then we'll take a look at the servers. Okay. So we see we have this new job called F drive. We get this little exclamation point, say it's resyncing, and the status is still resyncing. It's telling us the megabytes remaining, and actually just got into a mirroring state. So everything that was on there is now synced up across between Hyper-V 1 and Hyper-V 2. And so we have these green indicators that show us everything's good. So if there's ever a problem, in addition to logging to the event viewer, we also have these visual cues in DataKeeper that would alert you to a problem. And in DataKeeper, we also have some basic reports, especially if you're managing multiple jobs and multiple arrays and clusters. This gives you a nice job overview of all your jobs, or server overview. If you're connected to multiple servers, you can see the current status of your mirrors. So there's some reports built right into DataKeeper. Okay, so now we have this F drive, this volume replicating from, we see from Hyper-V 1, it's the source, Hyper-V 2, it's the target, and it's currently in a mirroring state. So go back to the Failover Cluster Management GUI, and now if we were to just create a virtual machine, let's say a new virtual machine on Hyper-V 1, we will let's say F drive VM. So we want to make sure that we're storing this on the proper location. So it's going to be on the F drive, the drive we're replicating. And we'll say next and next and next. And we're going to create a new virtual hard drive. Next. We'll install operating system later. This is just for example demonstration. And then we'll hit finish. And this will create the new virtual machine. And when it comes up, we'll see there's a warning because it's not associated with any storage. So if we view the report, we will see that the following disk path was found to there was no disk yet added to the cluster. And so what we're going to do next is go ahead and add that disk to the cluster. So we'll hit finish. So we have this new resource called it's a virtual machine resource, and we're going to just simply right click on that resource, and we're going to add a resource. We're going to go down to more resources and choose add DataKeeper volume. And so we have this new DataKeeper volume. We want to right click on that volume and choose properties. And we see that this is very specific to DataKeeper. We have a DataKeeper volume parameters tab. We need to associate this volume with that F drive that we just created, the F mirror. So it gives us the F drive in the drop down list. So we'll just hit OK. And so it finds all the information about the F drive. We know the current source, the target, the IP address, the mirror type, the current state. So all that is available right through the clustering GUI. So really, not really necessarily go back to the DataKeeper GUI at this point because you have all the information available to you right here. You may want to change the name. We'll say DataKeeper F volume, so we know what it is. And it's currently offline. Let's bring it online. And the last thing to do is to set up the dependency. So in this particular instance, we want to have the virtual machine configuration file dependent upon the DataKeeper volume. So apply and OK. So now we have dependencies. We'll bring this online. And so this is just a dummy virtual machine, doesn't have an operating system yet. But that's all there is to it. And I've shown you not only how to integrate the storage with failover clustering, but we've just gone ahead and created our first Hyper-V virtual machine resource, and now it's highly available, so I can simply, if I wanted to, this virtual machine is currently running on Hyper-V 1. If I wanted to do a live migration of that virtual machine or a quick migration, all those options are available to me. So it's simply click on, let's do a live migration. We'll live migrate to Hyper-V 2, and that's going to start the migration process, and then move it over to Hyper-V 2. And that will control the direction of the mirror as well. So simply by migrating it over, if we look at the data Keeper GUI, we will see that once it's migrated over, the F drive will be replicating. Now the source will be Hyper-V 2, and it will replicate back to the target of Hyper-V 1. So the live migration takes a little bit longer than the quick migration, but the thing about live migration is the virtual machine is accessible during the whole time of the migration process. So if this were an actual virtual machine, even though we're migrating, which means we're basically synchronizing the in-use memory of that virtual machine, it's available the entire time that migration is processed. There's a brief second in between you just saw where the machine would be unavailable during the actual switchover, but that's limited to just about a second. So we see everything is back up and running. It's online now. It's on online Hyper-V 2. So if I were to go back to and look at this volume, I can see now that we can see that the source is now Hyper-V 2, the target is Hyper-V 1, and it's currently mirroring. So we could now move everything back to Hyper-V 1 when we want to bring things back online in the original. So that's really it. It's pretty simple. There's not a lot that can go wrong, and it just ties in very nicely, and everything can be managed once you create the initial mirror. Everything else is managed through failover clustering, including the live migration, the quick migrations. If I had an unexpected failure, things would switch over just fine, and so that's all taken care of through their integration with Windows Server failover clustering. So thank you for your attention, and look for part 3 where we'll demonstrate how to put this all together with a SQL Server 2008 cluster. Thanks.